Quadratics, page 7. We're going to do number 4F. Here we have a quadratic equation which is in the vertex form. And since it's in the vertex form, what they're asking us to do is not so hard. Use the vertex axis of symmetry and y-intercept to graph. We can already see what the vertex is by comparing the equation to the vertex form equation, which is A, H, K. H and K are the x and y coordinates of the vertex. So here I have x plus 2, and if I compare that to x minus h, I can see that h is actually negative 2. So h equals negative 2, and k, you can see, is negative 3. So the coordinate of the vertex is negative 2 comma negative 3. And A, you can see, is negative 1/10. So first of all, we already know the vertex, right? So it said to use the vertex, axis symmetry, and y-intercept to graph. Once we know the vertex, negative 2 comma negative 3, we already know that the axis of symmetry is x equals negative 2 because the axis of symmetry crosses the vertex through the x coordinate. So we can already graph here that negative 2 comma negative 3 is the vertex, and there is an axis of symmetry going through the vertex vertically. The other point they want us to use is the y-intercept. The y-intercept is always easy to find because to find the y-intercept, we just set x equal to 0. So if we set x equal to 0, we can see that what's left inside the parentheses here is just a 2 because it's 0 plus 2. So it's 2 squared. And then we multiply that times negative 1/10, and then we subtract 3. And that gives us negative 4/10 minus 3. So that would be negative 3.4. Okay? So our y-intercept is negative 3.4, which is kind of hard to draw here. It's about a little bit lower than the vertex, but not very much, right? So we can see that it's a very wide parabola, which starts at the vertex negative 2 comma negative 3, but it only crosses the y-axis slightly lower at 0 comma negative 3.4. Okay, so it's a very open downward pointing parabola. And we know it's downward pointing because the y-intercept is lower, and also because it's a negative 10, so we know that it's pointing down. Okay, now we're going to go to 6, where we're going to locate the vertex for each of the following quadratic functions. So we have x squared minus 4x plus 2. There's a couple ways we can find the vertex. One is that we can use the axis of symmetry, x equals negative b over 2a. We just take the values for a and b and we substitute it in, and we get that b is negative 4, a is 1, and then it's the negative, and so the answer is 2. Okay, so the axis of symmetry is x equals 2. And once you know the axis of symmetry x coordinate is 2, then you can figure out the y by putting the 2 in the equation. And if we do that, then we can see that we'll have 2 squared minus 8 plus 2, and that will give us the y coordinate. Okay. The other thing we could do is we could graph it on the GDC. So we'll try one of those. So we'll turn it on. Let's turn it on. Okay. And then we'll put in the formula, which is x squared minus 4x plus 2. So x squared minus 4x plus 2. And we graph. Okay, and we can't see it very well. We'll do a zoom standard. Zoom standard is option 6. Okay, all right. So now we're going to find the vertex. We can find the vertex using the second calc function, and we go down to minimum because we want the minimum of the parabola, which is also for a parabola that points up. the minimum is the vertex. So I mark the left, and then I go to the right, and I mark the right, and then I hit enter, and it gives me that the minimum is 2 comma negative 2. Okay, and so that agrees with if we put the 2 inside here, like I said, we get 4 minus 8 plus 2, that would be y equals negative 2, right? And finally, the other way to do it would be to complete the square. So remember, when you complete the square, you take this part of the equation, and then you find out what the exact value you need to add to make a perfect square. And so actually you take negative 4 and you divide by 2, you get negative 2, and you square it and you get 4. So that's the value you want to add. So you add 4, and then you immediately subtract 4, so that basically you're adding 0, which is legal. Okay, and then you take the part that is here, and then you're going to find the perfect square of that. So that would be x minus 2 squared, right? And then this part you combine, negative 4 plus 2 would be negative 2. So you can see that this part that you combined here is the k part, and then the h part is the x minus 2, it's the 2. So all three of the methods end up finding the same vertex, which is 2 comma negative 2.